Okay, we are talking about the differential equations. You can see that all these parts of the first three questions, all these equations here, they are called the differential equations because you can see the dy by dx in it. You will be finding proper chapters on it in your A-level maths, inshallah. So now, look at this. For instance, question number one, part C. You have dy by dx that is equal to 7x cubed. When you want to solve this, you will be performing a cross multiplication here. Okay. Um, Now, one of the sides will have dy. Uh, one of the sides will have dy in it, and the other side will have dx in it. Now, that actually means that one of the sides would be integrated, like if I put the integration sign here. So now this means the left hand side is being integrated with respect to y, and the right hand side is being integrated with respect to x. So if I ask you that what is the integral of 2 dx, can you tell me what is the integral of 2 with respect to x?
X square.
2x plus c.
2x plus c, है ना?
2x plus c.
2x plus c. And now if you don't have like this 2 over here and you only have this dx, can you imagine that you have 1 over here, है ना? So if it is 1 dx, so its integral should be x plus c, है ना? Now similarly, can you tell me what would be the integral of just dy? You can assume that there is one. I'll not be writing that 1 over here.
Y plus c.
That is y, okay? So I'll just be writing it as y, and this is 7x raised to power 4 over 4 plus c. Now, some of you might be getting confused that I didn't write a plus c with this y. The reason being that one equation can have only one constant. So this is up to you. If you write plus c with the y, you will not write a plus c with the x wala expression here. So you only have to have 1 times plus c in the whole of this equation. Okay, so now this is the indefinite integration over here. If you look at the parts, for instance, I take you down here. Look at this question number 4. I'll be basically taking you to the question number 4. Now it says we have a curve such that dy by dx is this. Given that the curve passes to the point 0.05, find the equation of the curve. Define the equation of the curve. Now, the first thing, Bacho, you must remember that the moment you guys see this dy by dx while attempting your examination, the first thing that comes in your minds, that is the equation of a tangent, because you people have learned that dy by dx gives you the gradient of the tangent. But please see that he's asking for the equation of the curve, not the equation of the tangent. So how to solve that? So let's do that. Um, we'll be saying, okay, this is the fourth question here. We have dy by dx equal to this 3x square minus 4x plus 1. Now that will be my first step. I'll be cross multiplying it. So one side has dy, the other side has dx. And now I'll be putting the integration signs here. Now this means that the left hand side is being integrated with respect to y. So I get y here, okay? And this is going to be, now I am expecting you people to be really good at your integration, okay? This is 4x squared over 2 plus x. And then you have to write this plus c. Okay, so we have y equal to x cube minus 2x squared plus x plus c. You will be using this point now. He says it passes to the point
I
0.05.
had a couple of
This
questions.
one point is given
Intzar?
intentionally so that you can determine the value of c from here. So I'll be changing this y with the 5 and I'll put 0 as
So
x.
Intzar,
Yes, beta?
I had a couple of questions.
Okay.
Um, आपने जो हमने अभी तो किया था कि dy का इंटीग्रेशन इज y प्लस c,
Yeah,
तो
yeah.
फिर आप दूसरी आपने y प्लस c क्यों नहीं लिखा, आपने खाली y क्यों लिखा हुआ है?
Yeah, I think I have better given you the explanation because you know your whole equation. For instance, look at this. Suppose you have an equation. Suppose you have y plus 2 that is equal to x squared minus 5x plus 3. You will move this 2 to the other side, and finally your equation in the simplest form would be x square minus 5x plus 1. So do you agree with this or not? Hmm?
जी सर
Yes?
पर फिर जीरो हो जाना चाहिए सी.
Just listen. The thing is, the equation has just one constant in it. Now, suppose if I differentiate it, I really love you people when you ask questions. Now, suppose if I differentiate beta, what will I be getting? I'll be getting 2x minus 5. है ना? I'll be getting 2x minus 5. And now when I integrate it, that will be 2x minus 5 dx, है ना? This is dy. So, shouldn't I be getting this equation back? Hmm? है ना? So I'll be writing it as y equal to 2x square over 2 minus 5x, and I'll write plus c over here. I'll be writing plus c. If I have a point, suppose I have been given a point 0, 1 onto this line. So I'll put that point here. 1 equal to 0 plus c. I'll get that c as 1. Okay. So that would mean equation is going to be finally y equal to x square minus 5x plus 1. Therefore, you don't need to write plus c on both the sides because this is one equation. Okay. An equation can have only one constant in it. I hope I uh, tried to make it clear to you. Hmm?
जी सर समझ आ गई.
Okay, beta. So you have to write this C just once in your equation. And I was telling you that you will be given a point over here. You will be using this point to determine this unknown over here. Okay? Now, can you try this question number 5?
सर अगर आप हमें समझा रहे हैं तो आप म्यूटेड हैं.
Yes, I was muted. Okay, sorry. Let me tell you from the beginning, the fifth question. So we have dy equal to this. I was telling that we don't like these products while integrating. Okay, so that is why I have expanded this before I go on for the integration. So I get all of these things here, and now I have to use this point to determine this c. So this is minus 5. That is going to be 2 minus 3 plus c, and your c is going to be, I think that is going to be minus 4, I guess. Okay, you can check. This is y equal to 2x cubed minus 3x squared minus 4. So that is the equation of the curve, the equation of the curve which had this as its gradient, which had this dy by dx equal to 6x into x minus 1. Okay. Okay, now the eighth question. Now, eighth question is, let me right away start by shifting. This is dy equal to kx squared minus 2x, and then this is dx. Okay, I'll be integrating this side with respect to y, this side with respect to x. So, मेरे बच्चों, you see that it's going to be y is equal to kx cube over 3, and minus 2x square over 2 will give me x square, and then plus c. You can now see that why we are given a pair of points here. Anna, why do we have a pair of points this time? Anyone? Hmm?
सर ताकि हमें उन्होंने के नहीं बताया ना तो हम ग्रेडियंट लगाएंगे और फिर उससे हम फाइंड आउट
No,
करेंगे.
no, 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 no. Now don't mix this up with the gradient. The thing is,
Sir,
yeah, yeah, yeah.
सर हम ऐसे कर सकते हैं कि हम दोनों x and y वैल्यूज डाल के दो इक्वेशंस बना लें और समथिंग.
वही करेंगे. We have to do that thing. That is why we have been given 2 points over here. Okay, I'll first of all use this point 1 6. I'll have 6 equal to k over 3 minus 1 plus c. This is going to be k over 3 and plus c equal to 7. That is my equation number 1. And then I'll be using the second point, minus 2 minus 15. So that will give me minus 15. That is minus 8k over 3. And then I have minus 4. And then I have plus c. So we have minus 8 over 3k plus c, that is going to be minus 11. So that is my second equation. Okay, and you see that if I subtract these two equations, this is k over 3 plus c equal to 7. This is minus 8 over 3k plus c equal to minus 11. So by subtracting them, we get that 9k over 3, that is going to be 9k over 3 equal to 18. This is three threes are, so your k is going to be 6. And if I put this into any of these equations here, let me put that into the equation number 1. So I have c equal to 7 minus 2, that is 5. So finally, the equation that we have in this eighth question, that will be y equal to 6 over 3, that is 2x cube minus x square plus 5. So you have to have belief in your algebra, okay? And if he is going to test you with something like this, so be brave, okay? Just remember how to go for that. ठीक है जी. अच्छा, I will be moving to another exercise now and pick the question, the same topic from there. Now, this is another level of the same topic here. You can see that you will have to apply the second technique of integration. I'll be doing this third question from here. Okay, so we have dy equals under root 2x plus 1 dx. Okay, so here we go. We put the integration sign, and you must know how to integrate this now. This is going to be 2x plus 1 to the power 3 over 2. That is half plus 1. Okay? And that is over 3 over 2 times this, to never forget to write the derivative of whatever you have here. And then obviously plus c. Do you understand how important is this writing plus c now? Because on the basis of this, you will be getting the correct equation of the curve. Now this is y equal to 1 over 3 into 2x plus 1 raised to power 3 over 2 plus c. Now let's use the given point here. The point is given to us, that is 4 comma 11. So this is going to be 11 equal to 1 over 3 into 9 raised to power 3 over 2 plus c. This is 11 equal to, this is 3 square 27. This is going to be 9 plus c. So your c is equal to 2. Finally, the required equation is y equal to 1 over 3 into 2x plus 1 raised to power 3 over 2 plus 2. Okay? Acha. Now there is a very interesting question. I can see that that is your fifth question. Here is saying a curve is such that dy by dx is this. The gradient of the normal to the curve at this. Oh, very interesting question. Let me see how do you do that. Try this question. Okay, in this fifth question, there is a bit of differentiation involved here. It says a curve is such that dy by dx is this, where k is a constant. The gradient of the normal to the curve at the point 2, 2 is minus 1 over 8. Now, if the gradient of the normal is this, guys, do you remember dy by dx gives us the gradient of the normal or the gradient of the tangent? Hmm? Yes? Hello? This dy by
Gradient of
dx?
the tangent.
Yeah,
Tangent.
yeah, this gives us the gradient of the tangent. And what is the relationship between the gradient of the tangent and the gradient of the normal? Hmm?
They're negative reciprocals of each other.
Very good, beta. They are negative reciprocals of each other. So therefore, can I say that m is going to be 8? Because if I assume that this m is going to be the gradient of the tangent, then this is going to be 8, because this normal's gradient is given as -1 over 8. So using this information, this time we can determine this k first of all. So I'll be writing this as dy by dx ki jagah I'll be writing 8, and that is k into, we have been given this x coordinate. I'm using this x coordinate 2 here. So 4 minus 3 is 1 cube. So your k is right away, that is going to be equal to 8. So now we have got this dy by dx, that is going to be 8 into 2x minus 3 whole cube. So we have dy equal to 8 into 2x minus 3 whole cube dx. Okay, this cross multiplication step is the crucial one here. So let's integrate this. This is y equal to 8 into 2x minus 3 raised to power 4 over 4 into 2 plus c. Now this 8 is cancelled by this 8. So now let's use the point 2, 2. This is 2 equal to 4 minus 3. This is 1 raised to power 4 plus c. So your c is going to be equal to 1. Finally, the equation of the curve is going to be y equal to 8 into 2x minus 3 whole cube plus 1. That is the equation of the curve. Okay, let me see one more question, maybe from exponential or the logarithmic ones. As I look at this question number 6, I believe you people can do it yourself, because here it is given to you this d2y by dx square, that is equal to 8 e raised to power minus 2x. It says given that dy by dx is equal to 2 when x is 0, and the curve passes to the point, this find the equation of the curve. Acha, bacha, you people have learned how to find this second derivative. This second derivative is basically, now first of all you have y equal to blah blah blah, and when you find d by dx of this y, this becomes dy by dx. Okay? Acha. And when you differentiate this dy by dx again, this becomes d by dx of dy by dx. Okay? Now you will allow me to write it as d by dx of, बच्चों please समझना इसको, this is the proper notation of how to do it, because teachers do tell how to solve this, but they don't tell the proper notation. Now when I do the cross multiplication, I'll keep d of dy by dx on this side, and I will be shifting this dx to the other side. Okay, so now if the right hand side is going to be integrated with respect to x, the left hand side is going to be integrated with respect to all of this mess over here. Okay, so if you integrate just dx, you get c x plus c blah blah blah. If you integrate dy, you get y plus blah blah blah. So if you integrate this d of this, all of this, so you will be getting dy by dx equal to 8 e raised to power minus 2x over minus 2 plus c. Okay, this is cancel. I'll be using this dy by dx and this value of x to determine this c. So dy by dx is 2 and x is 0. This becomes minus 4 e raised to 0, that is 1. And this is plus c. So your c is going to be 6. Now, we have the equation so far. This equation is going to be now, this is, we have got dy by dx, that is equal to minus 4 e raised to power minus 2x plus 6. We have got this. Okay? Ab, this has become a normal question for you. This was something really new for all of you, where you splitted this d2y by dx square into d by dx of dy by dx. And the rest you can do now yourself. This is dy, this is minus 4 e raised to power minus 2x plus 6 dx. Okay, and I'm just completing this because I want to tell you one thing from here, that when you integrate this again, this is y, minus 4 e raised to power minus 2x over minus 2 plus 6x. Now, please don't use c over here again. You can write c1 or you can write kx, what, sorry, not x. Koi bhi, you can use any other letter instead of c because c has already been used in this solution. So this is cancelled by this, 2 is left. So let's use this point now, 1 comma 2 over e square. So we have 2 over e square instead of y, and this is 2 e raised to power minus 2 plus 6 plus k. You know that this is also 2 over e square. So your k is going to be equal to minus 6. Okay. So finally, your equation is going to be y equals 2 e raised to power minus 2x plus 6x minus 6. That is the equation of the curve. And I end this recording here.